I created an OpenAI DaVinci 3 voice assistant, then a Bing and GPT 3.5 Turbo voice assistant. Now I'm going to show how I created a Bard voice assistant. Out of all the large language model-powered voice assistants I have coded, Bard has taken over as the one I use daily. Unlike the GPT 3.5 or Bing API, Bard's responses return almost instantly. Bard can search Google to answer our questions with relevant live data. When Bard was first released, it was pretty trash. Within less than 2 months, Google has silently updated Bard dozens of times. Bard is surprisingly starting to outperform GPT 3.5 Turbo response quality. The fact that we have an API to interact with it for free makes me morally obliged to code a Firebard voice assistant.
Okay, Google. Who am I speaking to?
You are speaking to Bard, a large language model, also known as a conversational AI or chatbot trained.
For the sake of intro, I'm going to push Control-C. That's how you stop the bot from speaking. Okay, Google. Write a rap song about why ChatGPT is so much slower than Bard.
Yo, I'm Bard, the language model. I'm here to tell you about GPT. It's a chatbot that's slow as hell. It's like it's running on a Dell.
Okay, Google. Find me a 4-star hotel room in Seattle next Friday night for $150.
Here are some 4-star hotels in Seattle that are available next Friday night.
Okay, Google. I want to book a night at the Maxwell Hotel. How can I do that?
There are a few different ways to book a night at the Maxwell Hotel. You can book online, by phone, or in person to book online.
You may have noticed that unlike the previous voice assistants, this Bard one has memory of our previous questions. The Bard API automatically refers to our last recent questions for context. With the GPT APIs, we have to programmatically store the previous prompts and responses from ChatGPT and send them with our next prompt. That means, if we want prompt memory for context to our next prompts, we have to pay a whole lot more for every prompt's extra tokens containing all of the previous prompt, which means even on prompts where we don't need the memory, we pay for the tokens anyways. This is great for Sam Altman and Microsoft, but not for my broke boy wallet. The speed, free unlimited prompts, and conversational memory built into Bard makes it obvious which API is best for a voice assistant. Before we get into the code tutorial, you will need to get a Google account with Bard Access. It took me 30 seconds to get approved after signing up for their waitlist to get an invitation. Unfortunately, Google Bard is only available in the US and UK. Fortunately, VPNs exist. This program will require Python version 3.7 through 3.10 to use OpenAI Whisper. Older than 3.7 and newer than 3.10 will not support Whisper. Install for your operating system from the official Python site. It's worth noting that I will be doing this tutorial on a Mac. If you are on Linux, everything I do will be the same. If you're on Windows, it's worth noting this program will work, but you may need to do a couple steps different. Specifically in this next setup section of the tutorial, where I will be installing some dependencies in the Mac terminal. You will need to use Command Prompt and/or PowerShell. I highly recommend not attempting this with a Windows Subsystem Linux terminal, as it can introduce all sorts of errors that you will have to work around in setup. If you want a Linux terminal, I would recommend running a true Linux operating system. We will be using OpenAI Whisper for transcribing voice to text locally. To do so, we need to install a command line program called FFmpeg on Mac that requires Homebrew. For your operating system, follow these instructions from OpenAI to install FFmpeg. I can install Homebrew using this command on their website, then as recommended, install wget. Now, I can run this command to install our dependency. It will take a few minutes. Since I use the Python 3 command to open my correct Python installation, I will use pip3 to install my dependencies. If your terminal opens the correct Python version with just Python, use pip without the 3. I will start by installing the OpenAI Whisper library locally. Next, I need to install the reverse-engineered Google Bard API. I will be installing PyTTSX3. This will be used for local transcription on Linux and Windows. I won't actually use it to run the program on Mac. On Mac, PyTTSX3 isn't ideal, as we can do local text-to-speech by passing terminal messages directly to the Mac TTS engine. Now I need the speech recognition library. It'll be used to record microphone input. Next, install the Play Sound library. This will be used to play MP3 files. Lastly, we will install the PyAudio library. It is used for processing audio files and our other dependencies. On Mac, you may need to install another command line tool called Port Audio for PyAudio to work. Install that by typing brew. Install Port Audio in terminal. On Mac, we can make the program have a way better voice quality by installing the enhanced Apple voice models. Go to System Settings, type Spoken Content in the search bar, then click the system voice. In there, look for the enhanced voice that you like the most. I chose Zoe Enhanced. It may take a moment to install. Once we have selected an enhanced voice, our program will now use that. Now we have everything installed and can start writing some code. I will be using Visual Studio Code. It's a free-to-use code editor that has a ton of features and extensions to help improve the code writing experience. Download whatever code editor you prefer if you have not already, and let's move on to the next step. Create a folder named Bard wherever you prefer on your computer. Now open up your code editor and open the Bard folder. Inside the folder, I will create a new file within the Bard folder called main.py. Open that main.py file, and we will first write these 7 import statements. This will import all the necessary Python libraries to run our program. Let's create a variable we will call token. We're going to put our Bard access token here. To get the Bard access token, go to bard.google.com with your account that has access. Open the developer options for your browser, find the cookies tab, and click that. Within the cookies tab, we will copy the secure 1PSID value and paste it inside the quotes in our code. Next, let's create a chatbot variable to initiate the chatbot class from the Bard library. We will pass the token variable inside the parenthesis. Then we can initiate the recognizer class from the speech recognition library in a variable called R. Now let's load the Whisper base and Tiny model in separate variables. We will use the Tiny model for wake detection to make it as fast as possible. For transcribing our prompt to text, we will use the base model, which will work better for more complex voice input. When using the OpenAI Whisper library on Apple Silicon and other newer CPUs, it will print a warning message every time we transcribe text. It is simply to let us know it attempted to use the older FP16 method, which works better on older CPUs. It's not an error, but will confuse some people, and more importantly, fill up our terminal with unnecessary data. We want to keep the terminal clean and easy to read. With the warnings library, I can write this line of code to ignore these specific warnings. Now I need the program to check if the operating system is anything but Mac. I can do that by writing this line. It uses the SYS library to check the user's operating system. If the operating system is not equal to Darwin, it will run the next lines of code in our if statement. Darwin is what will show for Mac users. On the next line of code, we tab once to tell Python this is code inside the if statement. We can import the pyttsx3 library. On the next line, let's initiate the text-to-speech library inside a variable called engine. A lot of users complain about the speed of pyttsx. With these 2 lines of code, we can decrease the words spoken per minute by 50. Feel free to tune the speed to your preference. Okay, now we have imported and initiated all the objects we need for the program. Let's define a function for prompting Bard that takes a single prompt input. Functions in Python are code blocks that our program can use whenever we want to call on it later in the code. They can take input data, perform our code block, and return an output. Within our prompt Bard function, let's create a result variable to store our response from the Bard API. To send our prompt to Bard, we will call on our chatbot object we created earlier and use the ask function from the Bard library. We will pass the prompt input inside of the parenthesis. Now we can return the response. With the code as is, it will return a Python dictionary containing a lot more data than we need for our voice assistant. In Python, a dictionary is an unordered collection of key-value pairs, where each key is unique and maps to a corresponding value. We only want the value for the content key. Instead of returning the whole dictionary variable, we can select only the content value by typing it in brackets after the response with no spaces. Perfect, now we have a function to prompt Bard and return a clean response for our voice assistant. The next function will be to convert text to speech. Let's call it speak. It will take a text input. Then I will check if the operating system is Mac. If the operating system is Mac, we will create a variable called allowed characters. It will be a set containing all characters we want to send to the text-to-speech engine. This will help us send strings that come back from the Bard API with new lines and other characters that will stop the text-to-speech from functioning properly. Now create a variable called cleanText. Within the cleanText variable, we will write this inline for loop to properly format our output for the text-to-speech engine. On Mac, we can do text-to-speech in the terminal by typing the say command, then our input text. In Python, we can send terminal messages from the program using the system library we imported earlier. We create a terminal message and insert the cleanText variable to the command. If the operating system is not Mac, we will use the pyttsx3 library say, then run and wait function for text-to-speech. Now we have all our objects, a function to prompt Bard, and a function for converting text to speech. Let's define a main function that we will use to structure the rest of the logic for our program. First thing, I want to initialize the microphone class from the speech recognition library. I will call on the adjust for ambient noise function to help our program block out background noise from the voice input. Then, I will start a while true loop to run the rest of our program on a loop indefinitely. The program will run through the code in the while true loop, then start back over after completion. This will allow our program to always keep listening for a new prompt after it completes the previous prompt. Within the first while true loop, I will start another while true loop. The second loop will be for our wake word detection. Inside that second while loop, I will start a try statement. Then on the next line, I will print a message to terminal letting the user know the program is listening for the wake word. Now I can create a variable called audio. Within the audio variable, I will call on the R object we initialized and use the listen function to auto-detect speech input. I need to convert the audio variable to a .wav file that OpenAI Whisper can transcribe. To do so in Python, I will use the built-in open function to create a file called wake_detected.wav. Then I use the built-in write function to write the file data to our new file using the speech recognition getWaveData function. I will create a result variable and transcribe using the tiny model from Whisper. In a new variable called text input, I will select only the text from the Whisper transcription result dictionary. If Google is in the text input, we will break out of the second while true loop, so our code can move on to the next step in the program. If Google is not in the text input, I will print a message to the terminal telling the user to speak again. Now we can finish up the wake word detection try statement with an except statement. We use the try except statements to handle potential Python errors. If any errors occur in the wake word detection code, we will print a message to terminal saying an error occurred during transcription, then print the error message content. Without doing the try except statements, our program will print the error message and stop the program. By using the try except statements in Python, we get to control how the program responds to errors. By adding a continue statement, we tell our program to start back from the start of the try statement if an error occurs. Our wake word detection code is complete. I need to write some code to record and transcribe the prompt input, starting with a try statement. Then I will use the PlaySound library to play a notification audio file. Using an already existing less than 1 second .wav file will be much faster than using text-to-speech to alert the user. I downloaded this free stock sound from Pixabay. You can use whatever notification sound you want. Just make sure you name it wake_detected.wav and save it in the same folder as the Python program. I will now print a message to terminal to give visual confirmation to record the prompt input. Next, create an audio variable to record voice input. Using the same open function as in the wake detect code, I will create a file called prompt.wav, then write the prompt input audio to that file. Using the OpenAI Whisper-based model, I can transcribe the prompt.wav file into text stored in the result variable. In a variable called prompt text, I will select the text key from the result dictionary. Now I can print a message to terminal letting the user know their prompt is being sent to Bard. We will print the prompt input in that message. If we do not speak within a couple seconds of the program requesting our prompt, it will save an empty audio file as our prompt. Instead of sending that empty prompt to Bard, I want the program to ask for the user to speak again. I can use an if statement to check whether the prompt input text length is 0 characters. If the text length is 0 characters, the program prints a message and speaks to let the user know to speak again. On the next line, I will write a continue statement, letting the program know that when this if statement is executed, it needs to start back from the first line in the first while true statement. Finally, I will write the except statement for our prompt input try except code. With our program now able to actively wait for a wake word, then record a voice prompt after hearing the wake word, we now need the program to send our prompts to Bard and speak us back the responses. We can create a response variable and call on our prompt Bard function, passing the prompt text as input to the function. Now that we have our response from Bard, we want to print it to the terminal. I could just type print response. However, on Mac and Linux, we can write some code to change our terminal text output color when it is from Bard. This will make the terminal much easier to read. Using the SYS library, I will again check the operating system. If it is Windows, we can just print the response output. If it is Mac or Linux, we can write this code in our print statement that uses ASCII delete characters that will allow our program to print the output in a red font. I will call on our speak function, passing the response variable as input. That is all of the code for the main function. Lastly, I can start the main function by calling on it on the last line of code with no tabs before. That is all there is to it, 78 lines of code, and you now have your own fully functioning Bard voice assistant. If you enjoy these free code tutorials, make sure to hit the like button and subscribe. If you watch this far and are not interested in learning to code, but want to run the voice assistant on your own machine, I have included a GitHub link with the entire project for you to download. I wrote very thorough documentation that will guide you through setup without having to write any code. This has been another Python tutorial with AI Austin. I will see you in the next one.